Hello, this is Scholar Strive doing some math today in geometry. We'll be looking at some triangle sum properties, but first we need to learn some vocabulary. Interior angles. So interior angles. So let's have a polygon first. Let's do pentagon. And let's change my pen here. There we go. So an interior angle is any angle inside the polygon. So it's formed by the intersection of any of the two sides. So right here, inside there, is an interior angle. This one, or this one, or this one, any of those. And then if there's interior angles, there must be exterior angles. Exterior means outside. So if we draw that same polygon somewhat, and if we extend one of the sides, this angle here is called the exterior angle. And then we have the triangle sum theorem. So what it says is all interior angles add up to 180. So if I had 60, 50, and 70, those better add up to 180. So the three interior angles add to 180. And then the acute angles of a right triangle are always complementary. So if we have a right triangle, that means we have a right angle. That means the other two angles must add up to 90, because if there's 180 degrees in a triangle and you subtract that right angle there, you have 90 left. And complementary angles add up to 90 degrees. And then we have the exterior angle theorem, which says that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles or non-adjacent angles of the triangle. So what does that mean? So let's draw a bigger triangle here. So this exterior angle, let's call it 140 degrees, is equal to, and if that's, well, let's back up a little bit. So this is 140 degrees and this is a straight line. That means this angle has to be 40 because they add to a straight line. And what it's saying is that if this is 45 degrees, then this has to be 95 degrees. Oops. 95. So it's saying that this exterior angle, this theorem says that this angle here, the exterior angle, is equal to these two. Okay? So if you ever have an exterior angle, it's always equal to not the angle that it's next to, but it's equal to the other two angles in the triangle. Okay, let's classify some triangles. So we have a scalene triangle. A scalene triangle means that no sides are congruent. So this would be 5 centimeters, 7 centimeters, 10 centimeters. So they all have different lengths. An isosceles triangle has two sides congruent. So 4 inches, and those tick marks mean that those two sides are congruent. And then, let's say, 6 inches. And then an equilateral triangle, let's see if I can draw that. I can't. But all sides would be congruent. So that would be 8, 8, 8, And then we have acute triangle. All angles are acute. So now, oops. Let's go back down here. So an acute triangle, all angles are less than 90. Like 60, 61, and 59. Let's try this a little bit bigger. They're all less than 90. They're all different. And then the right triangle, we've seen this before. Triangle with a right angle. An obtuse triangle has one angle bigger than 90. And then an equal angular triangle, which is the same thing as an equilateral triangle. All the angles are the same. In this case, 180 divided by 3 is 60 degrees. So they would all be 60 degrees. Okay, what type of triangle is a scoring triangle in shuffleboard? How do you know? So this is an isosceles triangle. And that's because, well, the picture tells you by these tick marks that two sides are congruent, the same length. And then the third side is definitely shorter than the other two. So checkpoint 1, draw an isosceles right triangle. So an isosceles right triangle would look something like that, where this side is congruent to this side, and then we have a right angle. An obtuse scalene triangle. So that would be something like that. 6, 12, or maybe 9. Doesn't have to be that accurate, but something like that. And then this angle here is, I don't know, 122. Something bigger than 90, but less than 180. Alright, they want you to classify triangle RST by its side lengths. Okay, so if we scroll back up, sides, so there's either a scalene triangle, an isosceles triangle, or equilateral. So either no sides are congruent, two sides are congruent, or all three sides are congruent. So how do we find length if they're in a coordinate system? We use the distance formula. So remember the distance formula, let's write it up here, is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. So I'm going to choose 2 points. Let's find the distance of RS. So that's the square root of 5 minus 3 squared plus 2 minus 3 squared. In the case, if you haven't noticed, I'm using R as my first point and S as my second point. So x1, y1, x2, y2. So I'm going to get 5 plus 3. Be careful with your signs. Those two negatives make it positive. And 2 minus 3 is negative 1 squared. So 8 squared is 64, plus 1, or negative 1 squared is positive 1. So we have the square root of 65 for RS. Okay. Now, let's take a look at ST. Okay. I'm going to use... I'm just going to do top minus bottom. Okay, so 5 minus 3 squared plus 2 minus minus 1. So that would be the square root of 2 squared plus 3 squared, which is 4 plus 9, which is the square root of 13. Now, as you probably already tell, this is probably a scalene triangle where none of the sides are the same, but we got to prove it using our math. Okay, so the last one we need to find is TR. And then this time I'll do bottom minus top. So square root of 3 minus minus 3 squared plus negative 1 minus 3 squared. So here I'll have 6 squared plus negative 1 minus 3 is negative 4 squared. So 36 plus 16, which is the square root of 42. So this is a scalene. So this is a scalene triangle. All the sides are different. And now there was a different part of the question. So first we had to classify it by its side lengths. Now we have to determine if it's a right triangle. So how do we determine if it's a right triangle? We need a right angle, so we need to use the slope formula to see if any of these slopes are perpendicular to each other. So slope, remember, is y2 minus y1 over x2 minus x1. And so let's do the slope of RT. Again, I'm going to do bottom minus, or I'm going to do, actually I'll do top minus bottom this time. So y2 minus y1. Top minus bottom 3 minus minus 1 over negative 3 minus 3. So 3 plus 1 is 4, and then negative 3 minus 3 is negative 6. So this becomes negative 2/3 if we reduce. Okay. Now if we do what's next? ST. So the slope of ST to top minus bottom again over 3 or 5 minus 3. So 2 plus 1 is 3 over 2. And then now I have to go find the slope of, actually, no, wait. If we look at these, negative 2/3 and 3/2, those are opposite reciprocals because they're flipped. And opposite means if it's negative, it becomes positive. If it's positive, it becomes negative. So since they're flipped and they're opposite, That means they're perpendicular. So RT is perpendicular to ST. So yes, it's a right triangle. And that would be here, RT, ST. So that would be this angle here on the picture. All right. A lot of work in showing whether or not, if they put you on coordinates and they don't give you any distances, you got to find the length of each side if you want to classify a triangle by its sides. And then you got to find the slopes and see if two of them are opposite reciprocals to see if it's a right triangle. A lot of work. All right, find the measure of angle DCB. Okay, so DCB is this brown angle here. And remember, we have an exterior angle theorem that says, or let me figure out the correct name. Yeah, exterior angle theorem. Okay. That says that the exterior angle, so 3x minus 9, is equal to the other two non-adjacent, so not next to, angles in the triangle. So 73 plus x. Okay. Or the sum of the other two angles, not just equal. So sum means addition, so I'm adding these two angles together, 73 and x. Okay, and now we have an algebra problem. Subtract x from both sides, get 2x minus 9 equals 73. And then add 9 to get 2x equals 82. So x, when you divide both sides by 2, is 41. But that's not my answer. That is just x. We want the measure of angle DCB. So the measure of angle DCB is 3 times 41 minus 9. And that'll be 123 minus 9, so 114. The side of the wheelchair ramp shown forms a right angle. Okay. The measure of one acute angle in the right triangle is 8 times the measure of the other. Okay, the measure of one acute angle in the right triangle is 8 times the measure of the other. Find the measure of each angle. Okay. So let's call this x, and let's call this 8x. So that's 8x because this is 8 times the measure of the other angle. Okay. So if this angle is x, and we have 90 degrees here, then the other one has to be 8x. Okay, so to find the measure of each angle, we need some type of formula. Well, we know that all the angles in a triangle add up to 180. So x plus 8x plus 90 is 180. If I subtract 90 over, and then combine my like terms, so 9x equals 90, so x equals 10. Again, we found x, but we want the measure of each angle here. So x equals 10, that's one angle. And then 8x is 80 degrees, and then we already know the 90 degree angle there. All right. Triangle JKL has vertices blah 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 blah. Classify triangle JKL by its sides. Okay, distance formula again. So let's do JK, square root of I'm just going to be lazy and just do left minus right. So negative 2 minus 1 squared plus negative 1 minus 3 squared. So we get negative 3 squared plus negative 4 squared. Nine plus 16 is the square root of 25. What times itself is 25, and that's 5. Okay? So we have JK, let's do KL. And I'm going to go ahead and just do left, right again. 1 minus 5. And then 3 minus 0. So I got negative 4 squared plus 3 squared. So 16 plus 9. Okay, that's 5. So we have at least an isosceles triangle right now because 2 of the sides are the same. So let's look at LJ or JL. And I'm just going to do, let's change it up a bit. Let's do right minus left. 5 minus 2 squared plus 0 minus 1 squared. So 0 minus 1 is 0 plus 1. Okay. So I have 7 squared plus 1 squared is the 49 plus 1 is 50. So that's not equal to 5. So isosceles. Ooh, now I have to determine whether it's a right triangle. Okay. So remember this is y2 minus y1 over x2 minus x1. So slope of JK is 3 minus 1 over 1 minus 2, which is 4 over 3. KL, slope of KL, slope. 0 minus 3 over 5 minus 1, which is negative 3 over 4. Okay, yes, we do have a right triangle. Because JK is perpendicular to KL. So triangle, what's this called? JKL, triangle JKL is a right triangle. Checkpoint 3, find the measure of angle 1. So once again, the exterior angle, 3x plus 16, is equal to the other angle, is equal to the non-adjacent sum of the other two angles. So 52 plus 2x. Okay, subtract 2x from both sides. X plus 16 equals 52. And then subtract 16 is 36. Yep. But that's not what we're looking for. We're looking for the measure of angle 1. So the measure of angle. So we know that this is 52 degrees. And that's 2x, which is now 2 times 36, which is 72 degrees. So angle 1, remember, all the angles in a triangle add up to 180. So 180 equals 52 plus 72 plus angle 1. So 180 minus 124 will get me my angle 1, which is 56 degrees. The other way you could have done it, let me do this in a different color, is this angle plus angle 1 is also 180 degrees because they make the straight line. So 3 times 36 plus 16 plus angle 1 is 180. So 108 plus 16 plus angle 1 equals 180, and I should get 124, which I do, plus angle 1 equals 180, so angle 1 is 56. So either way, you'll get the answer. And that is all for section 1. Have a good day.